I've been working on these random number generators since I started using Macs in the early 1990s. This is the introduction to the new, more polished versions with lots of examples. I'm going to open up a README patcher, and I'll leave this on the screen for a few moments. I invite you to pause the video at this point and read this. It'll be helpful in understanding the things I'm going to show you next. The key to random number generation, and the way that I use it, is the seed. It allows repeatability. There's a seed object, which is the beginning, where you set the seed that will be recognized by all of the objects in the window. If I go over here to the rand object and click it 3 times, we get 2945. If I go over here, well, now let's see what the seed is now. So it's now worked its way around a cycle of 64 bits. If I set this again, note this number, click this again 3 times, 1, 2, 3, that's repeatability. Now there is a variety of these generators. RANF produces floating point numbers. RAN32 is now misnamed because it now produces 64-bit numbers. Random, spelled incorrectly, so as not to compete with Max's random, but it just produces, in this case, numbers between 0 and 1 less than the limit here, which is 12 now. We change that to 14, and we click on off. Well, you saw it go by. We'll get a 13, anything from 0. And it's random, so you might get the same output several times in a row. And we'll skip over these 3 for a moment. There's one down here, shuffle, which I first learned from James McCartney, and it shuffles. Now if we go back up to our seed and hit that, notice 312 ending in 76. Do the seed again, 312 ending in 76. So again, repeatability. Now if you read in the README thing, there are 256 threads or cycles of random numbers, and they can be assigned to objects, so that groups of objects can share a single seed, and so they will not be influenced by this seed, which is connected to thread 0 by default. But again, we get the same numbers. A couple of others I've put down here at the bottom. I don't use these very much, but random walk. So this is walking through a square of 16 by 16, and the each step is just 1 pixel either direction, or 1 slot in either direction. And it's actually a toroid. If it tries to walk over the edge, it pops back in on the other side. I've used this for a few things, but I'm happy to entertain some ideas about. This one is like the deal object. Well, I can't remember whether Max has a deal object. I think it does. So this is going to deal a single card from a deck of 52. And my late wife Leslie found these images, so we can do a little jazzy thing here. Now this message right here is going to set the seed to my zip code back in Oberlin, and then shuffle the deck. So if you do that and deal out the cards, same sequence. Probably useful in Las Vegas. Over here I'll come back to these. These are a variety of seeds that can be done. So if I use the same one as before, click 3 times, get the same number. So now I have a couple of examples of sound over here, something that is playing a sequence of random notes. And the sound is coming from my portable Grand DGX 660. And then you can automate a few things. This is the volume slider. And I like to set it up over here so you can actually hear the music. This is a menu of general MIDI voices, and again it's going out to the portable grand. Now here's a seed. Let's set it back to vibraphone. It's a little less intrusive of the voice. So if I repeat the seed, it pops back and does exactly the same thing it did before. Now let's go down here and look at this one. I forgot what's the difference. Oh, this is using the drunk object. Again, misspelled because there is a drunk in Max. This one's not behaving correctly at the moment. I'm going to fix this, but it's making notes that are way too big. And it's not talking to the portable grand. And we're getting some weirdness. This is a set of examples that are graduated in complexity from example 0. I'll show you, see, a simple metronome playing. Yeah, if we just click it, it's picking random pitch, random velocity, random duration as a multiple of 256 or 250 milliseconds. Stop it for a second, seed it. And so we get that repeatability again from the seed. And I'll skip to number 4 here, perhaps. It's off screen. There it is. A similar kind of thing. It's picking random voices too. Now I'll introduce you over here to the general MIDI band. It's part of Sonomorphs. It's a way of programming 16 channels of general MIDI and more the presets than I've, as you can see, more than I've ever used. This uses the pads and the FX, and I call it my space orchestra. And so let's just for fun change that to electric grand, hit the preset, and it comes back to that. So this is now going to use all of these, with the exception of channel 10. In general MIDI, it's always the drums, and I think it might still play some drums, but this skips the, if it selects a 10, it skips it, goes back and tries again. So let's just see what it does here. And it's not yet pointed at the portable grand. Now this mechanism up here, you see a key from the keyboard, number 52, happens to be the number key 6. And so these examples can be triggered together. I'll close this for now. Let's see, what is this over here? Oh, it introduces the pass percent object here. So if we're playing it, let's go over here and set all the channels to grand piano so we can hear it. And it's passing 75% of the bangs because of the argument here. A little rhythmic variety. And now we'll pick another, and it gradually increases it to 78%. And this one has got a line, and so every time you do it, it is a smooth transition from one density of rhythm to another. Okay, we're going to look at example 6 now. Notice that I've set the MIDI band so that all the channels are playing an acoustic grand piano. That makes the explanations a little easier. So example 6, it's a big one. The usual stuff, a note out that may not be set to, yeah, it is to portable grand. GLN make note 3 is a version that prevents hung notes. I won't talk about that now. Coming up from the bottom, there's something called the pitch sieve. So as these random notes are chosen, they are in this case sieved so that they go to the nearest note in a C major scale. And this set of sliders over here, that's the 0, that's 4, and that's 7. The pitch class is for C major scale, so let's just hear that. And this is that little thing where the general MIDI, no matter what you tell it, will play a drum on channel 10. It's picking random. Okay, so let's stop it for a second. We'll go up a little further. 4 bangs, unusual stuff. Then we get up here to the rhythm. This is from Sonomorphs, binary rhythm. It creates a set of clicks where 1 means play the bang, let the bang through and get played. 0 means don't. And in this case, the arguments are 8 pulses, 4 of which are randomly selected according to the seed to be ones. And so the rhythm is this kind of a so just for fun, I love prime numbers. I'm going to set 17 ticks, 7 of which are randomly 1. And let's set it to 13, a little more dense. Okay, so most of this is about sonomorphs, but we still have the seeds. So if we click the Oberlin zip code and the Santa Fe zip code, okay, let's look over on the right side where all the harmony is coming from. Again, the connection is pitch sieve receives chord, and chord is sent from over here and over here. These are menus with some common harmonies. Let's try a few of those. Major 7th chord, minor 7th chord, hexatonic scale. I think this one is the enigmatic scale. Okay, so in this case, the message is just coming direct from here. So over on this side, we have an harmonic interpolator. And you send the same messages here, and the chords change over a period of time. I'm not sure what it's set to, but we'll change it here. So let's change it so that it takes 4 seconds for the interpolation to occur. And this uses inside the ease package. So ease crossfade. That's a little messy, but clean her up. Okay, and so we can start playing again. And this one is continually outputting these chord messages, and as soon as the slider passes halfway, then that note becomes part of a message over here. Now we don't see that happening, but if we did, we'd see a lot of spinning numbers. Also, back to randomness, we can choose random chords. So this is a C sharp, D, E flat. It's a B flat, must be an A flat. And then finally, in this really extravagant example, if I throw this switch, after 4 seconds have expired, it mutates this. And then, because these are all following the same thread, random thread. Let's stop it. Let's turn off the harmonizer. The chord, let's just change it to a hexatonic scale. And now this change is turned off, so I'm not going to hit these random things over here. So the only random things are going to be here and okay, so all of these things are now in the single thread, and if I were to move objects around, then the random numbers would be picked in a different order, and I think that might be happening a little bit here. Yeah, probably caused by this thing. Sometimes this, let me just take that patch cord out. This is one where it's rejecting tens, channel 10, and now it should be but it's very sensitive to the positions because of the way Max executes things. It's sensitive to the positions of the numbers. So now if I'm lucky, if I hit that, yeah, there's still something out of order here. But that's a good illustration of why I'm doing all this. I need to have control over that. And that'll be the next example. Now the thing that makes all of this work is a feature of Max called the private variable. There's a PV object which you can give a name. And I'll show you how I'm using it. Each of these players has a reference to it. This establishes what thread number it's doing, and all of my random objects, like this one, contain the thread number in a random index or ran index, and every time it's executed there's a bang that comes down here first thing and reminds this object which thread it's in. There's an index message that then goes over to the basic rand object. And that's what keeps everything in order. And again, as an instance of, in this case, the A player has made, that private variable that is only known inside of each A player is set to the thread that it's associated with. And every time one of my random objects gets executed, the ones with the GLN dot on the front, reminds the object of which thread it's in. And with that in place, then well, there's still a problem if you move objects around inside one of those things. But I hope we all learn that, once we get an object functioning and we don't move, or a patch functioning, we don't move the objects around. Anyway, I'm going to insert this just before the finale because it's would be kind of anticlimactic. But that's how it works. And again, I'll be producing another video that's a much more coherent explanation of this, along with some real pieces, I hope, soon. Okay, now we've come to a fully functioning example that is getting pretty close to music, actually, which is the point of all of this. First of all, let's notice the change over here in the general MIDI band. I've added another ensemble which consists of pluck strings and xylophones and things that are hit. So I'll show you what it does before I try to explain how it does it. So notice the keyboard. That key is lit because I used it once before. That key is attached to my oxygen 49, and so the keys, each key on that keyboard triggers a phrase by setting some C's. Now here's what it does. Same key, the D key. and again. Different key, sort of similar to the other one. And that E flat again. Now, I'll attempt to explain it. There are a number of objects that would be used in every one of these applications. The first one is the set random threads. And what it, well, I'm going to have to show you several things. Let's look at the players. There are 5 of them, identical players, same thing, and they have corresponding to get random thread and get random seed. Now both of these things, you just put these into each object and it happens, things happen more or less automatically. So let me close this up and let's look at the inside of this object just for one thing. There's a collection over here. I'll bring it in. The collection contains, whoops, the collection contains all this information for this business, and here's the collection and what it looks like. And it's off screen. Okay, so we have the seeds for thread 1 through 255, and then 0 is the thread numbers, and since it starts with 7, it says that 6 threads have already been allocated. I know 5 of them went to each of the players, one each to the players, and I don't know where the 6th one went. So if something else comes along, if I were to add another player, this would become 8, and the C's. Now look at these numbers, 1, 7, 6, 8, 9, and I'm going to close this because it won't refresh, and now I'm going to hit that original key that I did. And while it's playing, I'm going to open this up again. And I hope you remember that number, but at least you know that it's different. And so what happens is that the key sets the seed for thread 0, which in turn sets 254, 255 other numbers that become the seeds for the other other things that are watching all of this. Boy, this gets complicated, but it all works, and I'm going to produce another video with a more coherent, perhaps, description of all this. But I think I'll just play it for a little while. And so here we go. And a new key will interrupt that. Hitting a key repeatedly will start it over. And for the recapitulation, well, it should be a familiar phrase by now as soon as this one finishes. A little distortion in the recording. That police whistle. So that's it for now. Be happy to try to answer some questions. I'm going to produce some pieces now, and I'm going to come back to this example and take it apart one one function at a time and hope to make a little clear how it all works. But right now it does work. Let's just for fun go back to the space orchestra. And the only thing that's going to change are the timbres. The rhythms and everything will be the same. Thanks for watching. Thanks for listening.